Genuinely useful humanoid robots will be coming next year, says Elon Musk, and this is the Tesla Optimus 2 robot that will be coming. Tesla will be putting humanoid robots into production within months, according to the firm's CEO. Steve Benford and Praminda Kaleb-Soli, Elon Musk's recent announcement on Twitter that Tesla will have genuinely useful humanoid robots in low production for Tesla internal use next year, suggests that robots that have physical human-like characteristics and provide genuinely useful function may be with us soon. However, despite decades of trying, useful humanoid robots have remained a fiction that never seems to quite catch up with reality. Are we finally on the crux of a breakthrough? It's relevant to question whether we are really in need of humanoid robots at all. Tesla's Optimus robot is just one of several emerging humanoid robots, joining the likes of Boston Dynamics Atlas, Figure AI's Figure 01, Sanctuary AI Phoenix, and many others. They usually take the form of a bipedal platform that is variously capable of walking and sometimes jumping, along with other athletic feats. On top of this platform, a pair of robot arms and hands may be mounted that are capable of manipulating objects with varying degrees of dexterity and tactility. Behind the eyes lies artificial intelligence tailored to planning navigation, recognizing objects and carrying out tasks with these objects. The most commonly envisaged uses for such robots are in factories, carrying out repetitious, dirty, dull, and dangerous tasks, and working alongside humans, collaboratively carrying a ladder together, for example. They're also proposed for work in several industry roles, service roles, perhaps replacing the current generation of more utilitarian meet and greet and tour guide service robots. They could possibly be used in social care, where there have been attempts to lift and move humans, like the Riker Robear. The Robear, admittedly, this one was more bear than humanoid, and to deliver personal care and therapy. There's also a more established growing market in humanoid sex robots. Interestingly, while many people recognize the moral and ethical issues related to these, the use of humanoid robots in other areas seems to attract less controversy. It is, however, proving challenging to deliver humanoid robots in practice. Why should this be so? There are numerous engineering challenges, such as achieving flexible bipedal locomotion on different terrain. It took humans about 4 million years to achieve this, so where we are now with humanoid robots is pretty impressive, but humans learned to combine a complex set of sensing capabilities to achieve this feat. Similarly, achieving the dexterous manipulation of objects, which come in all shapes and sizes, weights, and levels of fragility, is proving stubborn with robots. There has been significant progress, though, such as the dexterous hands from UK company Shadow Robot. Compared to the human body that's covered in a soft, flexible skin that continuously senses and adapts to the world, robots' tactile capabilities are limited to only a few points of contact, such as fingertips. Moving beyond automating specific tasks on factory assembly lines to impoverishing general tasks in a dynamic world demands greater progress in artificial intelligence, as well as sensing and mechanical capabilities. And finally, if you're going to make a robot look human, then there is an expectation that it would also need to communicate with us like a human, perhaps even respond emotionally. However, this is where things can get really tricky because of our brains. If our brains, which have evolved to recognize nonverbal elements of communication, don't perceive all the microexpressions that are interpreted at a subconscious level, the humanoid robot can come across as positively creepy. These are just a few of the major research challenges that are already taxing communities of researchers in robotics and human-robot interaction across the globe. There's also the additional constraint of deploying human robots in our ever-changing, noisy real world with rain, dust, and heat. These are very different conditions to the ones they're tested in. So shouldn't we focus on building systems that are more robust and won't succumb to the same pitfalls that humans do? Recreating ourselves? This brings us to the question of why Musk and many others are focused on humanoid robots. Must our robotic companions look like us? One argument is that we have gradually adapted to our world to suit the human body. For example, our buildings and cities are largely constructed to accommodate our physical form, so an obvious choice is for robots to assume this form as well. It must be said, though, that our built environments and tools often assume a certain level of strength, dexterity, and sensory ability, which disadvantages a vast number of people, including those who are disabled. So, would the rise of stronger metal machines among us further perpetuate this divide? Perhaps we should see robots as being part of the world that we need to create, which better accommodates the diversity of human bodies. We could put more effort into integrating robotics technologies into our buildings, furniture, tools, and vehicles, making them smarter and more adaptable so that they become more accessible for everyone. It's striking how the current generation of limited robot forms fails to reflect the diversity of human bodies. Perhaps our apparent obsession with humanoid robots has other deeper roots. The godlike desire to create versions of ourselves is a fantasy played out time and again in dystopian science fiction, from which the technology industry readily appropriates ideas. Or perhaps humanoid robots are a moonshot, a vision that we can all understand but is incredibly difficult to achieve. In short, we may not be entirely sure why we want to go there, but impressive engineering innovations are likely to emerge from just trying. And this is republished from the Conversation on the Creative Commons by Steve Benford, Professor, Collaborative Computing, University Nottingham, and Praminda Kalab-Soli, Professor of Embodied Intelligence, School of Computer Science, University of Nottingham, on Unexplained Mysteries. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.